Okay. So this is for the concave. This side we have concave mirror. Concave mirror. And this side we have convex mirror. Okay. So for the convex, that is the first ray. Now, what is number one? For the convex, the way they have showed you there. So you draw a straight line like this, and then afterwards you put the principal axis. This is the principal axis. And you put this to show that you are drawing a convex mirror. Then continue with the dotted lines, because we know that the principal focus of a diverging mirror is inside that mirror. So the principal focus is virtual. I think it is not the first time for you to hear that word virtual. So it is virtual, so it is inside that mirror. You cannot place something, cannot place an object at F of the principal axis because it is inside. Now the ray that is parallel to this principal axis, after reflection, this ray will appear to diverge from the focal point. So like that, to appear to come from there. So that is ray number one. That is ray number one that you should know. Then ray number two. Okay, we looked at ray number three. It was ray number three. Okay, it was ray number three, which is here. Let us see ray number two. Now, ray number two is the opposite. Is the opposite of ray number one. They are just telling you that if the ray is coming from the principal axis, then that ray is reflected as a parallel beam or as a parallel ray. Are you seeing very well? If the ray that comes from the principal axis after reflection is reflected as a parallel ray. Whereas here, even here, we are seeing that the ray that appears to come from the principal axis, this ray here appears to come from the principal axis, it is reflected as a parallel ray to the principal axis. So that is number two. Maybe number two, we can just note it down here, and we say that a ray through the principal axis is reflected parallel to the principal axis. A ray through the principal axis is reflected parallel to the principal axis, So you also do the same. You should know these things. You also do the same, and then you draw it. So this is for concave, and then we shall, if this is the focal point, so the ray from the principal axis, this is the ray after reflection to be a parallel to the principal axis. And also the side for the convex, the same way, draw a straight line, do this line like this, and then show that this is a convex mirror. Then put dotted lines for you to show where the principal focus is. Then if you have the ray that appears to come from this side, so we have this ray appearing to come from there, and this ray after reflection is reflected as a parallel to the principal axis. So these things are easy, just a matter of knowing how to do them. But if you don't know how to do them, please, you have to practice and try to draw them. Okay, and this is now the last one here, which I want to talk about. A ray through the center of curvature is reflected along its own path. A ray through the center of curvature. A ray through the center of through the center of what? The center of curvature through the center of curvature is reflected along its own path. What do they mean? That if you have a ray, first of all, let me first draw the concave mirror like that. So if you have a ray through the through the center of curvature C, and it is directed towards the concave mirror. Okay, that's the ray. It is directed towards the concave mirror. So after reflection, this ray is reflected back through the same path, so it goes back through the same path like that. That's what we are talking about. You should know that is pole. So that is for the concave mirror. And this side, if you want to continue with the lines, they must be dotted lines. They must be dotted lines like that. Then for the convex, this ray, which is like if you have this ray which comes from the center of curvature, okay, and this is the pole. Center of curvature is here. Sorry. Now, can someone tell me this is a convex mirror? Now, because we know a convex mirror, its points are inside, so we cannot have the center of curvature here. So the center of curvature is inside because its points are virtual inside there. So it means that now this ray that appears to come from the radius of curvature will be reflected along the same path. So if that is the ray moving towards the radius of curvature, like that, that ray is reflected along the same path after reflection. So you can see the difference with a convex mirror is that for it the focal point and the center of curvature, they are inside the mirror. Okay, they are inside the mirror, whereas for the concave mirror, the focal point and the center of curvature, they are in front of that reflecting surface of the mirror. Okay, members, are we together? So they are saying that rays incident on the pole are reflected back, making the same angle with the principal axis. So that's why I told you that the principal axis, if we have a ray along the principal axis here, that ray will be reflected back along the same path. Why? Because the ray is incident on the mirror surface perpendicularly or at 90 degrees. So if this ray that touches the surface of the mirror perpendicularly, then it means that it will be reflected along the same path. So it will not change direction because it is incident perpendicularly to the reflecting surface. So all those rays that are reflected, all those rays that are reflected towards the pole of the mirror along the principal axis, they will be reflected along the same path. So they are telling you that use at least 1 or 2 or 1 and 3. So you can use this one. This is 2 and this is 3. So you can use either 1 and 2 O1 and 3. Okay? For you to find the point of intersection of the image. And always where they intersect, if you use this, let's say you use this and this, where these rays after reflection intersect, then that means that's where we have the top or the head of the image. The head of the image is always at the point of intersection of those rays. Then the image position can be located by the intersection of two reflected rays initially coming from the object. That is also the same thing, which we shall see. Okay. So let us look at let us look at this thing. This one I've already talked about it. The normal due to the reflection to the mirror surface at any point must pass through the center of curvature. The normal due to the reflection, the normal due to the reflection at the surface, at the mirror surface, at any point must pass through the center of curvature. What are they saying here? Here, what they are saying is that, for instance, if you look at this number 3 here, this one here that we are looking at, it means that at this point here, the ray is touching this point at 90 degrees. So it is incident on the mirror surface normally. So if it is incident normally to the mirror surface, then after reflection, it must pass through the same path. It must pass through the same path. And for that ray, for it to be reflected, also comes from the center of curvature. So comes from the center of curvature and then passes back through the same path. Why? Because at this point, it is 90. It will be 90 degrees at that point. So you may wonder, you are saying that, this is now a straight line. How can this one be 90 what? How can this one be 90 degrees? So I've just used this for you to understand very well how this ray is being reflected, but we know how a curved mirror looks like. If I may change this side. A curved mirror, if it is concave, if it is convex, it will look like this. That is convex, this one. And you shade very well, not just a matter of, you must make sure that these lines are touching that surface very well, like that. Okay. So that will be a convex mirror. So I've just talked about that kind of ray. If this is the principal axis, okay, here we have dotted lines. So here, if we have point F here, and I measure this, 7 points. Okay. Then point C is somewhere there. Okay, point C is somewhere there. Then this ray that comes from this point, the one that we are talking about here, it will pass through the principal. I mean to pass through the center of curvature. Now, after reflection from the center of curvature, it will be reflected back along the same path. So, if this is the pole, so it means that at this point here, it is 90 what? It is 90 degrees. So that this ray that is incident on the mirror surface, no? Normally. So that's why it has to go through the same original path. So it is normal. It is normal. We are going to see how to derive those equations, the mirror formula, and we shall be using this for us to use this ray as a normal ray, and then we apply the laws of reflection. Then the image position can be, I think you have finished that, so let us look at this. Images formed by concave mirrors. But before I start, have you ever seen concave mirrors and convex mirrors? apart from seeing them in the lab? Have you ever seen them somewhere where they are used? Stephen, have you ever seen concave mirrors somewhere? Let us start with the concave mirror. Concave mirror, Naruvega, where have you ever seen? Where have you ever seen a concave mirror or convex mirror being used?
Telescopes.
In what? In periscopes.
Teacher, in telescopes.
In periscopes, they use concave mirrors. What is
reflecting telescopes?
Reflecting, yes. Reflecting periscopes. Okay. Reflecting periscopes. Reflecting periscopes.
Yes, you have said where have I ever seen it?
Yeah. They use a plane mirror or they use a concave mirror? There you don't know, isn't it? Now, Rebecca, have you ever seen where we use a concave mirror or convex mirror? Now look at this. You have never seen where we use a concave mirror. Now, Rebecca, are you there? Okay. So, Stephen, let me tell you. Stephen has gone off. So, Stephen, let me tell you. In periscopes, what they use refracting mirrors. Those refracting mirrors, they are plane mirrors. But where we have concave mirrors, used by dentists. Dentists, they use concave mirrors, and we shall see why they use those concave mirrors as dentists. Where we also have concave mirrors in torches. Torches have got concave mirrors inside, so you should know that. Then convex mirrors are used as cast side mirrors. Those cast side mirrors have convex mirrors. Yeah. You and Mary. Mary? Hey, you mean at home you don't have cars to see the side mirror? That car that you have at home, doesn't it have side mirrors? Huh? It has. So you can study very well. When Papa comes back or when Mommy comes back, you can study very well and see their nature and get out yours that you used when you are in the morning when you are I don't know how to say, but when you're practicing how to smile, that's what you can use that mirror, bring it out, and also you walk towards the car side mirror and compare and see how are they in nature. Touch and feel that convex mirror, and then you understand the difference of the convex mirror from the plane mirror. Okay, so now let us look at how images are formed by a concave mirror. Number one, so the nature of the image formed by a concave mirror is either real or virtual, depending on the position of the object along the principal axis or the position of the object away from that mirror. So we are going to start. If I'm to draw, we are going to use straight lines. We shall not use curved kind of illustrations. So I prefer using a straight line. And this time we are seeing object between F and P. Object between F and what? F and P. So object between F and P, where is the image formed? So let us see. So you come and draw You draw your 1 meter. First of all, you draw this line to illustrate where your pole will be, and then you draw the principal axis into that. So at this point here, remember we are looking at a concave mirror. So you do this. Draw that. Okay. Then afterwards, we are going to put the center of curvature and the principal focus. So you should know that the radius of curvature is twice the focal length. So if this is my point P, which is, sorry, my point F, principal focus, there, then if this is 3 centimeters, okay, Stephen, what should be the distance from here, from the pole to the center of curvature, if this is 3 centimeters? What should be the distance from the pole to the center of curvature? That is 3 centimeters. It is what?
Yeah, the 3
3 centimeters.
I'm saying is the 3 centimeters for the focal length.
Focal length is 3 centimeters. So what should be the radius of curvature?
In the center of curvature from the pole of is 6 centimeters.
6 centimeters. So it should go 6 centimeters. What you can do? Okay, that is it. So this is where we have the center of curvature, like that. Now they are telling you that the object is placed between F and P. So this is where the object is. Yes, I'm going to show you where it ends. Okay, let me do another one. Okay, that's where the object is. I'm going to draw it on the single line. Now, for me to determine where the image is going to be located, I'm going to use my two rays. So I'm going to first use the ray which says that a ray parallel to the principal axis, from the object is reflected along the principal focus. So a ray parallel to the principal axis. This is the ray I'm drawing from the top. All rays come from the top. So that is the first ray parallel to the principal axis. That ray, after reflection, it passes through the principal focus. From this potassium, up to where iron is. It will pass there. Okay. It pass where? Now, at that stage. There, like that. All right. This is what we follow there. Now, all of them react with acids. Now, the other ray I'm going to use is ray number 3, which says that a ray from the object through the principal axis is reflected along the same path. So this one here. So from the top of this object, I'm going to put a ray like that. So it is going there, it is going towards the mirror in that direction. But after reflection, it is reflected along the same path like that. So here it goes towards the mirror, but after reflection, it is reflected along the same path. But now you can see that this is the first ray and this is the second ray. So the first ray and the second ray, they are not what? They are not intersecting anywhere. They are not intersecting anywhere. So what I'm going to do is I'm going to extend on the principal axis. Okay, inside. And now I'm going to also extend this. If I extend this ray, then the extension I make is apparent. It must be an apparent ray. So apparent rays are drawn in dotted form. Okay. I think after somewhere, I don't know, after somewhere they will intersect. Then the other one also, I'll put this. The other acids like nitric acid oxidizes D. Then also this one must be dotted. So where they meet, and this point where they have met is where I have my my image. And that image must be perpendicular. That's the image. So this was the object, and now this is our image. That's our image. So that image is virtual. So if you are told to write the nature of this image, the nature of the image, nature of the image, nature of the image. Without looking at my notes, what's the nature of the image? It is what?
Magnified.
It is magnified. Magnified. What else?
It's virtual.
Hey, Stephen, where are you? It's virtual.
It's upright.
Another one, it is erect, or you can say upright. Any other? Any other? Stephen, do you have any other? Okay, I think those are some of the and lastly, it is virtual or it is behind the mirror. It is the same thing. Virtual or behind the mirror, it is also the same one, the same thing there. So the property of concave mirrors to form erect, virtual, and magnified image when the object is placed near to the mirror than its focus makes it useful as one shaving mirror. So a concave mirror is used as a shaving mirror when the object is placed between the focal point and the pole of that mirror. Also, it is used by dentists, for the teeth examinations. So when you hear someone, I've gone to the dentist, even one day if you get a problem with your teeth and you are going to the dentist, be very keen. If it needs you to ask, doctor, where is the concave mirror? Can I see it? The one that they use for examining the teeth. You ask for it, and then you get to know that these are not lies, but this is true gospel. This is a true gospel. Okay. So that's the nature of the image formed by the object placed between F and what? F and P. So I would request you to go ahead and practice the second one. Practice the second one. Have you finished? Narveg, have you drawn the second one? Object at F, the image is, so we are going to write the nature here. Very well, nature of the image. Narveg,
Yes, teacher.
you are very low. I don't know why. Yes. So, let me just show you if the object is placed at F. Stephen, are you there?
Yes, teacher.
Have you tried to do this? Stephen, you are eating banana. Yeah? Okay. Suppose this is our concave mirror there, and this is F, and this is C. Okay. So we are going to place the object at point F. Are we together? Point F. So the first ray. Now I'm going to ask Stephen. Stephen? Stephen? Stephen?
Yes,
Stephen?
teacher.
Hey, I'm asking you. Now this ray, where is it going to pass? Is it going to pass at C or at F after reflection? Where is it passing?
It's going to be reflected to the principal axis.
Through the principal axis, correct? So through the principal axis. But I asked you a point. You have said F. That means for you went back and read. Huh? Okay, it will be reflected along this point here, like that. Okay. That is it. And then the other one, let me try to increase this. The other one comes from the top of the object, and this ray will pass through the center of curvature. So it has to go. It has to go like that. And then afterwards, it is reflected back like that. Okay. So it goes, and then it is reflected back. So what do we note here? Where is the image, members? If I'm to extend this, these rays, will they meet? Will these rays meet if I extend them? Members, are you there?
Yes,
This senior 5.
Yeah, we are there.
This senior 5 class, I don't know what's wrong with members. They tend to keep quiet as if they are still settling some businesses. Huh? As if they are still counting some money. So here we can see that at this point here we can see that the image is at what? At infinity. Is at infinity. So the image is formed at infinity. Is formed at infinity. Are we together? Even if we extend this one, it will not. So note image formed at at infinity. Formed at infinity. It is formed at infinity. Sorry, this I is not there. Infinity. Then the other thing is that the image is virtual, but now we don't know the nature of that image. So we are going to just write only this. We don't know whether the image is upright or it is virtual. So that is the only thing that you have to note down. It's only formed at infinity. So sometimes I have these notes, but we have to go through them and then you get to know what is right. Okay, then lastly, in the 3 minutes, object at F, sorry, object between F, object between F and C, object between F and C. So members, next lesson, do not miss, because we are going to look at these derivations here. Are you seeing these derivations? Yeah? So don't miss. You're going to look at those derivations plus. If you knew how to do this, I don't know whether you know how to do this. We would have skipped this part and go to the other section. But some of you will say, teacher did not teach us even on Zoom. Yet this is P2 work. P2 work. P2 work. This is P2 work. So image between F and C. So I'll come and draw my F and C. So I'll put here a ruler. So this is F, this is C. Put F, this is C. So between F and C, I'll put my object here. Object there. This is the pole. I'm dealing with a concave mirror. The first ray is this one. Okay. Then it is reflected along. Like that. So it becomes a ray with arrows. Are we together? Then the other ray here. Oh, now I can do this one. So this one I cannot. I know if I use it, I will get the answer, but you see where this one is. So I will not use that ray here. But I'm going to use the second ray, that a ray that comes through the principal focus is reflected as a parallel ray to the principal axis. So this is the ray, like that. So it will be reflected. So it must be parallel. This one must be parallel. Must be parallel. Must be parallel. Must be parallel. Okay. Where the two meet, that's where we have the. So this is where we have the image. So the image is not dotted. The image appears dotted if it is inside the mirror, if it is the other side of the mirror. But outside the mirror, it is full. So this is the image. So we write the nature of image. One. Start narrating the story.
It is magnified.
Magnified. Two.
It's real.
It is real. Thank you for copying.